Hello, everybody. How are you today? Can you hear me?
Yes.
That's great. That's great. So let me share my slide. All right. Can you see a slide?
Yes, you can say it.
All right. That's great. So welcome to 42991 Advanced Water and Wastewater Treatment. Yeah, I'm very happy to tell you that today is our last day of the formal consultation meeting. Thank you for joining this Zoom meeting. So today I will share the several questions and answer from last 2 weeks. You remember the last week we discussed about the overall assignment 3 and the block 3, and then I shared some of the question from students. Also, I got several more questions last 1 week. And first, let me share what students are very much wondering for this assignment 3. And then I'm sure that you may have similar issues from the other student question. So I will just go through the for last 1 week question I received. It's almost to 20 questions. I just to extract something is very important. So this is the first question. Is it okay to insert the report generated by web for my RO design in the appendix sections? If so, can I submit the whole report in a PDF format, as it would be easy to combine to PDF? Yeah, I strongly recommend that you submit in Word format, not the PDF file, because we want to make sure that your similarity, even though PDF file can make a similarity, but PDF file can convert to the image file. So I recommend you to submit your Word file, and then your auto design from Wave. Of course, there is a function to make a PDF file, whole report, but I want you to extract which is important part and then incorporate in the appendix rather than put all together. So that's not my key point. So just you paste it from the important information, and that should be no problem. So that's my suggestion. So if possible, I want you to submit in Word format, not the combined PDF format with your Wave report. Also, another question, the capacity of 250 megaliter per day is the product water or feed water? So I replied to the student, 250 megaliter per day is product water, which means the produced water. So if you have a 50% recovery, your feed water should be 500 megaliter per day. So the issue will be depending on your process and your recovery, and you could change your final product volume, so that I want to make sure your product water is always 250 megaliter per day. So when you design the sum of the capacity, that's always most probably it will be product water, permeate water, and produced water. So make sure your starting point. If we have 50% recovery, it has to be total capacity of 500 million liter per day. So you design for produced water. Okay. Also, some of students, they face a problem for the web software. It looks like this is the one of the message student just emailed me, and somebody bulk import project failed to import following project. So this issue is because of your old version. So when you have your software, just let me share my version of web file. Let me share. Okay, this one. Can you see the my web software program, right? So you can go to the about wave from help. About wave. So your wave version installed should be 1.81, which is the most latest version of wave software. So I strongly recommend you utilize this wave version 1.81. I think the error message which I showed you before from the slide is because of previous version 1.7. So you can download 1.8 from the canvas in our website. Also, you can also download the Dow Chemical DuPont water solution. So you can download the latest version, and you must have a 1.81 so that you can easily get your own result from your web software. So making sure have a correct version. Also, you have some guideline for the installation, such as when you have so when you have your, let me share this screen. So wave software icon. So you just make a property compatibility, and then you must tick the run the program as your administrator. Otherwise, it will be very difficult to save and modify your file. So that's the two important message you have to follow from your. So everybody follow this way of the latest version of wave software, and then your administrative role will make easy to operate your software. Do you have any question from here? No question?
Excuse me, sir.
Yep.
So I had a question regarding the section of this part. Once we shut down the system and the
shut down
operating system.
Okay, you're talking about this one. I have
Yeah,
I have several questions from students. So if possible, can you wait for me a little bit, and then we can go.
Yes, sir.
We can be there in maybe 2 more slides later.
Yes, sir. Yes. No,
Is that all right?
Thank you.
All right.
Yes, and along with this also, I just had a question regarding for the ions concentration. So like once in the software, should we put the ions concentration which was given by you in the file?
You're right. That's true. In the file, it's okay, as well as in the scenario, You know that
Yes, sir. Yes.
in the scenario, I also provide the sum of individual ions, right?
Yeah.
So
Yes,
you
sir.
can, if you have an individual ion, you will see, okay, can you see this slide?
Yes, sir.
Okay, you can see the sum of the RO solubility warnings. So barium
Yeah.
sulfate will have a more than 100% saturation point. So which means you need to add anti-scalant for the system. So
Yeah.
if you put the individual ions, so you will get the detailed information. Also, one of question in the your one of question is about the boron concentration. So
Okay. Yeah.
how do you ensure you have satisfied the boron limit of 0.3? So boron concentration, you have to see your program, which
Yeah.
concentration decreased less than 0.3. So you have to add your boron concentration. So I recommend you to see your scenario, incorporate your individual ion, or
Okay.
you can utilize my example file. So you can
Okay.
utilize a little bit of modified version, and
Oh.
you need to address your boron concentration in the
Okay.
report. So
Okay. Yes.
that's,
So the main concern will be regarding to the boron concentration to get it less than 0.3. Yeah.
yes, you're right.
Yeah. Okay. Okay, sir. Okay. Thank
That's
you.
true. So if I show, mm, let me share my software. So okay, can you see my software?
Yes, sir.
Wave, yeah, this one. So when you click the summary report, this is an example of, and let's look at the boron concentration. So your final permeate total is about 0.39, right? So it's more than 0.3. So you can go for the redesigning. Okay, I want to put another pass. So you can design another pass, and then let's see. So what's the stage you can put? So you can put everything, and then you will have a better concentration removal of boron, right?
Okay. Yes.
So that's I recommend you can show. So individual ion, yeah, you can briefly put your ion compound as much as you can, and then boron concentration will be one of the important. Other one is the very useful when you see, when you see the different solubility owning. For example, like a red color, can you see arrow
Yes.
solubility owning?
Warnings.
Your stability index is more than 1. Calcium fluoride more than 100% saturation point, anti-scalant is needed. So based on that, you can see red color 0.5, 1.5. This red color means you have some inorganic scaling or solubility issue, right? So
Yeah.
you can justify in your report. Okay, you need to put the anti-scalant in your program. So if you go to your configuration, RO reverse osmosis, so you can see the add chemicals and
Yeah.
degas. So you just click there. So you have a pH, degas, pH, anti-scalant, right?
Yeah.
So in this case, you can put, okay, I want to put the anti-scalant to sodium phosphate, and this will give, okay, let's say 3 milligram per liter. So if you put your, okay, I want to put the anti-scalant. So you can see the red color right here. So
Yes.
when you have a chemical, okay, I want to change the pH using hydrogen sulfate, pH 5. Let's say I want to reduce pH 5. So based on that, you can see the how much you can change your RSI value, and then how much you can change the red color using pH. Let's say if you don't have anything, you can see
Yeah.
red color how they change, right?
Yes.
So based on that, you can address your report, how you can improve your design in terms of chemical dose. So
Okay.
I want to that you can put the individual ion, especially boron, and then you need to see more detail. Also, this question is very similar. The entire RO system is perfect, except for solubility. I'm confused why the barium sulfate would be higher than 100%. In addition, I have branded anti-scalant chemistry before pass one. Why does the simulation advise me to supplement it? Because yes, you can see the barium sulfate, the before pH adjustment, then pass one after pH decrease, and then RO permeate. So you increase the barium sulfate, your concentration. So in this case, you can also further decrease the pH and then increase your anti-scalant concentration. If not, we need to look at also pre-treatment. So that's the way we have to look at the. Otherwise, you need to see the less recovery ratio, which will give you better result of your potential of barium sulfate scaling issue. So you can just decrease your water recovery, and that could be also one of the options. Okay.
Okay. Yes, sir.
So
And
next
so for
question.
the input concentration, we will directly put 500,000 million liters per day. Will the
500,
software work for the for 500,000?
500,000. Where is the
Yes.
500,000 from?
No, sir. Like for the permit recovery of 250,000 million liters per day. Like if you want to perform it in this Wave software, so will it work? Because like in your recorded lectures, it
All
said that for some it just works for certain amount, and after that,
I see, I see. Okay, so your question is about, okay, you want to design
yes, yes, sir.
500, you want to produce 250, in fact, 250,000 cubic meter per day, right? Yep.
Yes, sir.
This is your produced water, right?
Yeah.
So you need to make 50% recovery, right?
Yes, sir.
So which means 500,000 cubic meter per day. So this is exactly what you're talking about. Ratio of the feed water you have to design for 500,000 cubic meter per day, right?
Yes.
But the issue is, so your question is very similar to question from next slide. So
Okay.
this is exactly what you're talking about.
Yeah.
With the help of the software, we can calculate things regarding to the RO only. So we have to design for the capacity of 250,000 cubic meter per day. In software, can I take a product water as a 5,000 cubic meter per day and start my calculation? And then banks and all the things multiply by 50. So do you understand me? What's the this question is about?
Yes, sir. So we just like take the ratio and we just multiply it at
Exactly.
at the end.
Exactly,
Okay.
because when you design the final capacity, like when you design when you design 250,000 cubic meter per day, so you need a lot of RO, stage, RO, pressure vessel, RO membrane. So there are a lot of errors, and then
Yeah.
you will have a lot of calculation issues. Do you understand me?
Yes, sir.
So we can make a very simple. Okay, I want to do okay 200, or I want to do maybe 5,000, 1,000, 10,000. Let's say so 10,000. So you need the 25 same trains you need to design. So you not only design for, let's say, 10,000 cubic meter per day, and then you can multiply 25 times. So you will
Okay.
get your total capacity of your desalination plant, and then this will be the another maintaining issue. Have a one train cleaning, you can stop the one train, and then you can change those membrane. In the meantime, the other train will be continuously operated. So that's the way we can continue to operate, maintain, and then fix the issues. That's the what we can maintain this kind of design, right?
Okay. Yes, sir.
So that's the uh, that's the same question. You have this one. Also, regarding your question, let's get back to your question. In the section, I have to provide shutdown, operation, restarting, planning for plan. So in the
Yes.
operation, have to describe technical way that how RO-based desalination plant works.
Okay.
So in fact, we don't really uh, a lot of technical way to say that how the RO desalination plant work. So this one we discussed the last consultation time. So just let me share. Let me share the. Can you see the
Yes, sir.
numbers? Okay.
Yeah.
So let me share the Zoom. So this is the what we discussed last time. Can you hear the voice?
No, sir. It's not audible.
Okay, now okay. This is the That's the same question we discussed last week. Providing this will start out how detailed does the procedure, and then how maximize marks in this section. In the scenario, it states that the citizen water is using renewable energy. Based on this one, I assume that our startup will have to include how we power it enough and then store this energy, and operation for the wind technology to make plant work when needed. So this is the similar, not exactly same question, but yeah, we can make. Let's see the shutdown. So you don't have to show all the technical way, and then
Okay.
we can show, for example, 1 or 2 pages diagram or table. So I want to show you. Mhm. So this is the previous example. So shut down and then restart. So you can just try to utilize reference and then summarize how you can proceed with the shutdown and then
Okay.
reoperation. And then you can give a little bit of schematic and then procedure or just table. So you can summarize the step 1, step 2, step
Okay.
3. So that will be
Okay.
a summarized form you can utilize. So if you can see the last week Zoom meeting in
Yes.
the
Yes,
canvas,
sir.
yeah, so you will see how it looks like.
Yeah.
All right.
Yes, sir. Yes, sir. Like, because even in your recorded lectures, there is like some part around 1 minute or 2 minutes of explanation regarding to the plant shutdown and
Yes,
plant
you're right.
restart process.
You're right.
Yes, sir.
That's true. That's
Yeah.
true. That's true.
Yeah.
So is it clear about this shutdown? Yeah.
Yes, sir. Yes. Yeah. Thank you.
That's great. And then next question, you gave us example of the assignment. In that example, the full calculation table of equalization tank, strainers, and microfiltration pretreatment is given into the table. I haven't any idea how to calculate all the things. Should I have to assume all the things? The answer is, uh, in fact, this class, you can answer based on your, okay, this is the report. So what's the answer? What's your question? What's the answer? So in fact, you don't have to design all the detail for intake, strainers, microfiltration. Of course, if you can, that will be a great report and that will be great. But if you can just answer what's the question about background, what's the question about the desalination assessment, what's the question of shutdown, that's the what I'm trying to tell you. So you don't have to follow exactly same procedure for all the detail from intake to outtake or outfall design. So just to prioritize our report question and answer it as a report format. So if you have more energy and time, yes, you can also incorporate some more extra information for your design that will give you the extra mark. So it's completely up to you. Okay.
Hello, Professor.
Yeah,
My
yeah.
name is Chintan.
Yes, Sintan, how are you?
I have asked this question. Fine, sir.
Yeah, yeah.
Uh, Sir, so can I explain general information regarding to the app, MF and strainer? What is this application and all the things instead of intake and
You are right. You can briefly, because no matter what the question of, let me show you this one. A process flow diagram clearly shows your selected intake design, pretreatment process, and the RO process, any other relevant processes. So you can show what's the function of this flow chart, what's the process, what it's doing, very,
okay?
very, clearly you can mention about your flow diagram here. So that's you can briefly cover a little bit of design and then your function of the different processes.
So no need to give the information about the intake and outflow and all the things.
I don't think intake and outflow are not that much important because this is more about pipeline and then construction related issue, not really require very serious design because you need the diameter, you need the pump, then how
Yeah.
much you have a 500,000 cubic meter per day. So you can easily, how much, diameter, how much pumping, you can easily calculate, right? So depending on the velocity of your water volume. So this one, yeah, and it's not very, complicated. So you don't have to worry about all the detailed intake, outflow design.
Okay. Thank you, Professor.
Yeah. Okay, so that's the next question is about the software. Already we discussed, yeah. So you should have a very clear mind for this one. And then assignment 2, exam. This assignment 2 final marks. Some of them already received, and then Dr. Sharupuncha, he mentioned to me today he will finalize by this week, and then you will receive your final mark. So most of you, have you ever received your assignment 2 marks?
Yeah, Professor, I get the marks.
Yeah, you got it, right?
Yes,
so
sir.
already,
Even I
yeah.
got the marks.
So individually also Sharup email with the feedback. So if you have any question or if you need some of the clarification of your marks or feedback, please contact Sharup, and then he will discuss with you for the details. All right.
Professor,
Yes.
I want. Sorry.
Yeah, that's all right. You can ask me.
Yeah, Professor. Professor, I want to ask regarding to the Wave software. In this software, I take a product water as a 10,000 meter cube per day, and in reverse osmosis, I have take a pressure vessel on the first stage, 66, and for the second stage, it is 24, and elevation. ELS per pressure vessel, and the first stage 7, and second stage, I also take the 7, and I also add the uh, scalant, but still I get a problem according to the BASO4, which is greater than 100. And
all right. Okay.
yeah.
That's fine because you can you share your screen, please?
Professor, I use my mobile, so and all the things are in laptop.
Okay, so okay, that's fine. All right. So I will just tell you that okay, in this case, you can mention about your barium sulfate still more than your saturation solubility, so that you need to also address in your report saying that you need a special pretreatment to remove barium sulfate using some coagulant or some of the more anti-scalant will be needed for this barium sulfate scaling potential issue. So that should be no problem. Okay?
Yes, sir. Thank you.
All right, that's great. How about other questions?
So just to clarify, from 31st of the following and thus 31st May, we have 1 more week of extension, yeah, to submit a report.
Yeah, we were supposed to submit your assignment 31st of May, next Monday, right?
Yes, sir.
But yeah, a lot of students, one of question. So a lot of students, they have a difficulty to complete to improve their overall quality and understanding of assignment 3 because some of the capstone or other assignment have been overlapped so that they ask the extension. So yeah, I will give you one more week. So extension will be extended for 1 week. So which means you can submit your assignment by 7th of June.
Okay. Okay. Thank you so much, sir.
Yeah. So I hope that you improve your quality as well as the understanding of seawater desalination design. Is it okay?
Yes, sir. Thank you.
All right. So that's the what I have prepared. Also, if you need more, yeah, please just email me, and then I will also communicate through email. Also, if you need any help, just let me know, and then we can organize the Zoom meeting individually, and then have a session based on your problem for your assignment 3. Also, I am sure that this assignment may not cover all your expertise of the advanced water and wastewater treatment design. So if you need more, yeah, definitely you can consider your PhD, or if you have a more professional career, if you need, and then you can also further study will be considered. So that's my suggestion. Okay, thank you very
Professor,
much. And then, yeah,
I can share my report.
uh, now you can share.
Yeah, Professor.
All right, just a second. Let me
Yeah,
let
I
me
have a report. So
let me let me give you my. So just a second. Let me. Yeah, can you please share it?
yeah, Professor. Can you see, Professor?
No.
1 minute. Yeah, this report.
Oh yes, I can see that.
And I used these chemical doses,
Yeah.
but still I get a one warning like
Okay. Why you put the sodium hydroxide
where?
in the chemical dose? 4 milligram per liter of the sodium hydroxide. So do you have a software with you in your computer?
Yeah, Professor.
Can you open the software?
Yeah. Can you see?
No, you have to re-share the screen
Yeah.
for your program.
Sorry, Professor, but I cannot do.
All right. Okay. I think that because I don't know why you put the 4 milligram per liter of sodium hydroxide, which will increase your pH. That's the little bit of. Okay.
Why they remove it or?
Can you go? No, go. Yeah, you can remove, completely remove the sodium hydroxide.
Okay.
Can you go down? What's the saturation percentage of your barium? You are talking about barium sulfate, right?
Yeah. Yeah. That warning I will show you.
Here's the two warnings.
Yes, okay, volume update. Can you go down?
Yeah.
Okay, your pH just second. Okay, 183, 184, 183, 330. Okay. So you can possibly remove barium concentration just before pre-treatment. Like you may have to use coagulation to remove barium, so that that could be decreased your concentration. And you can mention about in your report. You can say that okay, because no matter what, your pH looks okay because your pH is 8.6, 8.4, 8.4. So which means past 1 feet after pH decrease, you have a 6. So which means your pH looks all right, but just make sure that your barium concentration can be removed by pre-treatment.
Okay.
Because your chemical already you put the anti-scalant, also you can increase the little bit more anti-scalant, and then see barium concentration and then mention in the report for your discussion.
Okay, Professor.
All right.
Yeah, Professor.
Okay.
Yeah.
Hello, Professor.
Yeah.
Hello, Professor. I just joined a bit late.
That's all right.
I was like, the Wave software in my laptop is not actually working properly. So, is there any laboratory in our college where we could where I could do the testing for my Wave software?
Okay. What's the problem for your? Why it doesn't work properly?
Because the feed flow earlier I used was around 50,000 meter cube per day, but I reduced it to 10,000, but still it's not working. Like the laptop is a bit old. So can I use a UTS laptop or UTS computer where Wave is installed, or should I, how should I work on it?
Is it your laptop software problem, or is it like your calculation problem? You mean the software problem? Is it software problem or your design calculation problem?
No, I mean like my laptop is old, so it's my laptop problem, and software is heavy for my laptop.
I see. Okay, because of the COVID-19, we have not arranged the UTS computer lab for this software. So you cannot use university computer. So okay, so your what kind of the OS operating system do you use?
I have Windows 8.1.
Windows 8.1. Okay, where did you download your software? What's your version of your software?
It's 2019 version. Like I installed it from the one you send it in the modules through the canvas.
Okay, can you share your software through?
I'll share with you the screen.
Okay,
If that's fine.
Okay, can you share the screen with me, please?
Yes, sir. Hello, sir.
Yeah. Can you share your software?
Yes, sir. 1 second. One second, sir. So,
all right. Okay.
So, Professor, it's still working on it. It's not like I'm trying to implement it. Like
Uh-huh.
it's like doing it
Okay,
on
can you
both.
just a second? Can you go up, go up, go up? Can you click the help on the top? On the
Quick
top,
help.
help, yeah, help.
Yeah, it's not.
No, 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 no. Just in the software.
Okay, just 1 second.
Yeah.
This,
Just to
yeah,
click, no, left. No, 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 don't. Okay.
which one? This one?
Yes, yes. Help. And then about wave. Can you click about wave? Okay, your version is 1.7. So you need to download again 1.8. The latest version is 1.8. So you can download from the canvas. You can go canvas again. There is the latest